Whole numbers introduction. So let's move on to a new type of number. As you know, in mathematics, we don't just work with numbers randomly, we like to organize them. We often group numbers into different sets. Think of a set like a collection, based on what characteristics they share. Now, if you recall, we've already talked about natural numbers. These were the numbers we use for counting, 1, 2, 3, and so on. Today, we're going to expand on that idea and explore the set of whole numbers. Whole numbers are very closely related to natural numbers. In fact, they include all the natural numbers, but with one important addition. That additional element is 0. So, we're taking everything we know about counting numbers and adding 0 to the mix. This might seem like a small change, but it actually has a big impact on how we work with numbers, as we'll see in the upcoming slides. Definition of whole numbers. So let's move on to formally defining what whole numbers are. As you recall from the previous slide, we were building on our understanding of natural numbers. Those are the counting numbers like 1, 2, 3, and so on. Now, whole numbers take that idea a step further. The first point here states that whole numbers are the set of numbers consisting of all natural numbers, and 0. So, we're taking everything we had with natural numbers and simply adding 0 to the mix. The next line clarifies this a bit further. It says that whole numbers are, in other words, non-negative integers. Now, non-negative simply means not negative, and an integer is a whole number, no fractions or decimals. So, non-negative integers are numbers like 0, 1, 2, 3, and so on. They can be positive or 0, but never negative. Finally, we have a way to represent the set of whole numbers mathematically. You see this notation. W equals an opening curly brace, 0, 1, 2, 3, 4, and then 3 dots. What this means is that W is used to represent the set of whole numbers. The curly braces indicate a set, and everything inside them lists the elements of that set. So we're listing 0, 1, 2, 3, 4, and the 3 dots, called an ellipsis, indicate that the pattern continues infinitely. It means the list goes on forever, including all positive integers after 4. Keep this notation in mind, as it's a concise way to talk about the entire set of whole numbers. On the next slide, we'll look at how whole numbers relate to natural numbers and how they differ. Relationship between natural numbers and whole numbers. As we discussed on the previous slides, we started with natural numbers. Those are the counting numbers, 1, 2, 3, and so on. Now, we've introduced whole numbers, which include those natural numbers, but with one important addition. This slide states that natural numbers are a subset of whole numbers. Now, the word subset might sound a little intimidating, but it simply means that everything in the natural number group is also found within the whole number group. Think of it like this: all squares are rectangles, but not all rectangles are squares. Similarly, all natural numbers are whole numbers, but not all whole numbers are natural numbers. The key to understanding this difference is, again, 0. Remember, we defined whole numbers as natural numbers plus 0. So, 0 is the extra element that makes the whole number set bigger than the natural number set. Let's look at the illustration. Here we see the set of natural numbers, represented by the capital letter N, and it lists 1, 2, 3, 4, 5, and so on, indicated by the 3 dots, meaning it continues infinitely. Voiceover. Then, we have the set of whole numbers, represented by the capital letter W, and it lists 0, 1, 2, 3, 4, 5, and so on, also continuing infinitely. Notice that the whole number set starts with 0, while the natural number set starts with 1. Voiceover. This simple difference, the inclusion of 0, is what defines the relationship between these two sets. We'll build on this understanding in the following slides with more examples and applications, so make sure you're comfortable with this concept of a subset and the role of 0. Let's move on to slide 3. This slide clarifies how natural numbers and whole numbers relate to each other. Examples of whole numbers. Let's move on to some examples to really solidify our understanding of whole numbers. Example 1, the question here is 5 a whole number? The answer is yes, and let's think about why. Remember from our earlier discussion, whole numbers include all the natural numbers and 0. 5 is definitely a natural number. It's one of the counting numbers we started with. Since all natural numbers are automatically included in the set of whole numbers, 5 is indeed a whole number. Now let's consider 0. The question is 0 a whole number? Again, the answer is yes. This is a key point. We specifically defined whole numbers as including natural numbers and 0. So, 0 is a whole number, even though it isn't a natural number. Don't forget that distinction. Let's look at a negative number. The question is -3 a whole number? This time, the answer is no. Remember when we said whole numbers are non-negative, that means they cannot be negative. Whole numbers start at 0 and go upwards. Negative numbers like -3 are not included. Finally, let's check a decimal. The question is 2.5 a whole number? The answer is no. Whole numbers are what we call integers. That means they are whole, complete numbers, no fractions or decimal parts. 2.5 has a decimal part, so it doesn't fit the definition of a whole number. So, these examples should give you a good feel for what qualifies as a whole number and what doesn't. We'll build on this understanding with a visual representation on the next slide, which will help to further clarify the relationship between natural numbers and whole numbers. Visual representation. Let's move on to visualizing what we've been discussing. This slide shows us how we can represent whole and natural numbers visually, and that's by using a number line. Remember from our previous slides, we established that whole numbers include 0 and all the natural numbers, that is, 1, 2, 3, and so on. Now imagine a straight line extending infinitely in both directions. At the very center, or wherever you choose to start, we place 0. To the right of 0, we mark points representing 1, 2, 3, 4, and so on. These are our whole numbers, and also our natural numbers. Essentially, the natural numbers begin at 1 and continue infinitely to the right, while the whole numbers also include 0, which is to the left of 1. This number line gives us a clear picture of how the set of whole numbers encompasses the set of natural numbers, with 0 being the additional element that defines the whole numbers. This visual will be helpful as we move forward and start looking at operations with whole numbers, because it reinforces the idea of their order and magnitude. We'll be building on this foundation, so make sure you have a good grasp of what this number line represents.